So I'm Dr Jag Srai. I head up the Centre for International Manufacturing here at the Institute for Manufacturing, University of Cambridge, Department of Engineering. And great to see a lot of familiar faces on the call. We've got see people from both the US, so good morning to you, and mainland Europe. So good afternoon to you, and I guess some people just joining in from the Far East. So welcome everybody. I'd like to go through some work we've been doing on the digitalization of supply chains. I'll be talking through 30-40 slides for the next 45 minutes, and then we'll leave a quarter of an hour at the end. Perhaps if you want to use the chat room to ask any questions, that'll be fantastic. So just an outline of the talk that I'll be giving over the next hour. First area we'll be looking at is just a feel for how we have conceptualized the digital supply chain. And that allows us to think about our scope and what are the key activities. I'll be moving on to looking at some digital scenarios for transforming supply chains and some of our observations from industry and some of the key challenges and opportunities, particularly from an adoption perspective. And finally, I'll be looking at some experimentation of some of the tools we've been looking at before we move on to future research. So slide 3 talks about some of the digital technologies, the 9 technologies that we've been looking at in terms of transforming industrial production. So here's a report from the OECD, and you see a lot of familiar concepts here around big data analytics, augmented reality, additive manufacturing, and so on. And I guess a lot of these terms will be familiar to those on the call. And one of our key questions were, how do these technologies, the Industry 4.0 technologies sometimes referred to, how might these impact the supply chain? That's pretty much the subject matter of this talk that I'm giving today. So the first part of looking at this was to frame the literature, and there's a lot of work we see in this diagram reference to digital factory. So manufacturing operations digitalized to improve factory efficiency. We see a lot of literature on informed logistics. That's being able to understand the flow of goods and materials through the distribution chain to customers, both in the business-to-business context and the business-to-consumer context. And on the right-hand side of this chart, you've got the product going to the consumer, and there perhaps the focus of digital has been on outcomes. So has the product performed as expected? And finally, at the top of this concentric circle diagram is through life management. So looking at e-life management, monitoring of equipment, or monitoring indeed of performance. So the digital supply chain, as we've conceptualized it, links through from the inbound logistics to the digital factory, outbound through informed logistics, where the focus may be on availability of goods, through to monitored product usage, and finally through life or e-life management, where the well-being of the asset is of primary importance. Now, in the middle of this diagram, we've identified a new network of individuals that are part of this digitalized supply chain, and we phrase that as connected communities or users, support specialists, as well as the primary firms involved in this digital supply chain. Now, the next chart starts to look at the digital infrastructure that might support that supply chain to operate in the way I've just described. So we might look at the use of sensors, connectivity, Internet of Things, information, and where that information may be housed in terms of the cloud, for example. So you have a digital infrastructure that underpins the digital supply chain. And substantial literature has been very much focused on that infrastructure itself. And finally, moving it into a specific context. So here we've looked at the pharmaceutical context and how experiments being undertaken by firms give us an idea of how digital may transform the conventional supply chain. So, for example, in the digital factory, you might have experiments around continuous processing or more distributed manufacturing models where manufacturing takes place closer to the consumer. You may have within the packaging environment smart packaging that allows goods to be better traced, and also in terms of the provenance of the supply chain. Moving through to informed logistics, we're seeing a lot of innovations around last mile logistics and e-commerce supply chain, but also, as shown in this iconic diagram, around just-in-time packaging or filling of goods direct to the consumer. And then as we get to the monitored treatment and usage area, we might see the use of mobile apps or wearables, for example, where we are capturing information on use of the product, receipt of the product, and performance of the product perhaps directly from the user. And completing the circle, as it were, you start to look at through life management. And in this case, it could well be of the patient themselves. In other contexts, industrial contexts, it could be the well-being of the asset, a refrigerator, for example. So for us, this was a way of conceptualizing some of the literature around the digital supply chain, the supporting infrastructure, and the widely reported experimentation that's been taking place within the industry. So we set about trying to explore, as part of our industry problem-driven research and collaboration, how digital supply chains are actually being implemented. So we developed a structured framework for looking at this activity. This was informed by both the literature and exploring experiments being undertaken by a consortium of companies, some of which have been shown there on the chart. And we're continuing to work with some of these, such as ABB, IKEA, Caterpillar, Grundfos, etc., as part of our ongoing conversation on the adoption of digital technologies within the supply chain. The framework itself, depicted in the middle of this chart, is a 10-scenario framework, and I'll spend a little bit more time explaining that. But we've also socialized this not just in individual companies, but through a whole series of workshops, one sponsored by the British Standards Institute, for example, others around healthcare, and also in our international symposium, our annual symposium, which on the topic of architecting the digital supply chain, discuss some of these transformation scenarios in a bit more detail. So our industry problem-driven research and collaboration has involved in-depth case studies involved with some of these consortium members, as well as these broader workshops with a whole range of industries. So to explain the framework in a little bit of detail, we've been looking at two scenarios on the two ends of the supply chain. On the procurement end, around collaborative e-sourcing, and this is about seamless connectivity with your supply base. And on the downstream side of the supply chain, the customer end, looking at the connected e-commerce. And here's where we've been looking at e-commerce transactions that a lot of us are used to procuring our retail shopping through various platforms, and the Amazon platform or the retailer platform, that is very commonplace, and trying to look at that customer connectivity through these platforms. And these are two scenarios at the two ends of the supply chain. Another four scenarios we've identified, both in the literature and in the experimentation that we've witnessed in industry, has been around these top four scenarios, which are pretty much bounded within the factory walls. So here we're looking at digital factory design, real-time factory scheduling, automation within the factory, and digital production processes. So a few words on these. On digital factory design, here we're looking at how 3D modeling tools are used to improve the flow of materials within the factory floor. Real-time factory scheduling is very much about flexible manufacturing through advanced execution platforms. Scenario 4 is around flexible factory automation, and this is very much captured in the Industry 4.0 technologies. And in digital production processes, a whole series of production process technologies, such as 3D printing, continuous processing, etc., that might be supported through process analytical technologies that monitor how production is taking place. These 4 scenarios reflect digital transformation within the factory operations. And the last 4 scenarios I'm going to touch on are around the end-to-end supply chain, from the extended supply chain real-time monitoring, often referred to as control towers or watchtowers that monitor product and quality through the supply chain. Digital product quality, where we are able to capture the quality and provenance of materials throughout the way through the production process and through to end use through digital information. Scenario 9, around digital supply network design. This is where we're looking at the manufacturing footprint and the distribution operations between factories, warehouses, various distribution hubs and the end user, and how might we optimally design that through digital tools. And finally, scenario 10 around product lifecycle management. So these 10 scenarios put together demonstrate for us some of the key transformation activities, both reported in the literature, academic literature, the great consultancy literature, but also in terms of observation from industry. And these are covered in a bit more detail in this publication, which is available through our website on next generation digital supply chains, and I've got that also shown on the chart here. So do download that and get more information on the definitions of these 10 scenarios. And I've just included in this slide as a way of recording all 10 in terms of the definitions and the classification of these transformation scenarios. So here, what we're envisaging is organizations will be adopting some or many in combination to produce a digital transformation that could operate in terms of improving margin, productivity, labor efficiency, etc., or indeed competitive advantage by changing the way organizations operate through perhaps reconfigured supply chains and business models. Now, in our assessment process, we use a series of maturity models to look at the opportunities, the risks, skills gaps, and the technology gaps that these scenarios have suggested. So through individual case studies with organizations. And one of our workshops with British Standards Institute, we had a number of organizations set out across sectors what their skills gaps and technology gaps as set out in this chart. And as you can see, quite a significant amount of skills gaps and technology gaps. And if anything, the skill gaps perhaps more significant than the technology gap. So we're seeing in applications across industry rapid advances in the technology and a somewhat catch-up activity within terms of the skills required to adopt and implement. And I'll be touching now on a few of the reasons on why I think adoption can be quite problematic. So a piece of work we've done with the OECD and UNIDO in their annual investment report is we looked at investment in the digital economy. In part of that activity, we wanted to look at what were the examples of digital adoption that we could already see within the industrial sectors and the retail sectors. So digitalization of service supply, mass connectivity between consumers and suppliers. We've seen that very much evident in the media. Not many of us will be going to procure individual videos or CD streams, but perhaps we'll be downloading them directly to our homes. Financial services, insurance, and the sharing economy in terms of Airbnb and the Uberization of a number of technologies. So in the area of digitalization of service supply, we see the current maturity very high. In the area of consumer personalization, we're seeing e-commerce continually to increase year on year. The activity between business to consumer increasing at a very rapid pace. And online sales now really threatening some of the more traditional bricks and mortar operations. So again, a very high adoption, challenging the traditional bricks and mortar retail with this adoption of an e-commerce driven consumer platform. As we move into the more hardcore production areas, we see some adoption of automation, particularly in production intensive industries. We've seen the use of big data to also support predictive analytics within supply chains, particularly with retailers, looking at seasonal products and indeed in the healthcare area. And here the adoption is more modest. But if we move on to the next chart here, we're looking at examples of digital adoption within manufacturing. And here adoption has varied from being very low to low or at most medium. So lots of hype around 3D printing, for example, a lot of conversations around manufacture to order, or perhaps the remote monitoring of industrial equipment, 3D printing of larger items is now taking place, but again, adoption is relatively low. So we're trying to explore why is it within the manufacturing space adoption is more difficult. Part of some work, I sit on the World Economic Forum Future of Production Council. A piece of work we've been looking at is adoption levels of digital supply chains within this group. And this chart sets out technology adoption within manufacturing. And you see early adoption and awareness pretty much widespread, whether it's a SME or a larger multinational. Quite a lot of evidence of some experimentation or piloting. But in terms of full adoption at scale, very little evidence. And in our conversations at the World Economic Forum, we're looking at this transformation perhaps taking 10 years to really start to become a significant activity. But we'll also see some sectors adopt faster and some geographies adopt faster. And looking at different country readiness levels, for example, piece of work undertaking the World Economic Forum started to look at what were the global leaders in these Industry 4.0 technologies and their adoption. And you see some of the advanced manufacturing economies, Germany, Japan, being very much in that category. Interesting analysis suggests that some of the larger new manufacturing giants, India, Turkey, Mexico, Hungary in Europe, could indeed have some challenges in terms of digitalization and come under the category of legacy champions. With some very much interesting new entrants around some Scandinavian countries and some of the more developing economies in Southeast Asia and the Middle East. So adoption will be dependent on the sector and perhaps also in terms of the national infrastructure in terms of being able to take these technologies forward. So this chart summarizes these categories between the global leaders, where there's a strong current base, positioned well for the future, and the countries that are emerging as a high potential, where perhaps there's a limited current base, but positioned well for the future in terms of their skills and developing their infrastructure. So that's around the readiness of countries to take on this digital transformation. Now, just to share a little bit around the applications across different industries. So in this simplified supply chain diagram, we have a number of columns around the upstream supplier integration. Second column around industrial internal production processes. Then moving downstream into customer relations. And finally, some observations on the end-to-end processes and governance that we can expect in these digital supply chains. So what we're getting, so some of our observations on these examples of digital transformations may be in the supply side around e-auctions with open or closed systems, digital twins within the manufacturing operation, with manufacturing closer to the point of consumption, moving further downstream about mass information connectivity between customers and suppliers. And in terms of end-to-end governance, clearly very much in the news lately, the emergence of new data management system requirements. So lot of system integrators now emerging, lots of data now moving between organizations. So what are some of the governance issues that might throw up? So in these different examples, we're seeing adoption in different sectors. So in discrete assembly sectors, we're seeing a lot of that inbound supply chain development. Within the manufacturing process around 3D printing, local production models for small-scale items and spares is where 3D printing perhaps is taking off. And in the retail sector around e-commerce, so e-commerce transactions in terms of fast-moving consumer goods with rapid last-mile distribution. And this is also throwing up opportunities for enterprise-wide data system capture and supporting watchtowers and control towers that I mentioned earlier. So just to conclude on this particular slide, we're trying to look at what are the international production implications of these changes. So what we might see is in the e-auctions arena with open systems, you might have a democratizing effect. Or if these platforms become closed systems requiring accreditation to operate on those platforms, you might have an exclusive effects being impacted on suppliers. Within the production process, digital twins can perhaps support more controlled offshoring and outsourcing, where assets could be owned or perhaps part of non-equity partnerships. Within the downstream operation, information on end user usage and performance could support more disintermediated models of production, driving a more servitized model or an outcome-based contracting model. And finally, in terms of end-to-end processes, frequent reconfiguration of production locations might support a more footloose behavior where organizations move between locations much more quickly as they are able to replicate production in a more reliable manner. And from a data perspective, the openness of data flows would support, would also govern whether investment takes place. So are we able to capture data from these more networked operations? Some examples of application across different industries. Now, a few examples in detail. We've been looking at last mile cost to serve models with a number of organizations, and it's been part of our major research activity going forward. And on the left-hand side of this chart, you can see the typical task of moving product between factory locations to different consumer drop-off points and shipment points. And the whole cost of what's the optimum distribution pathway. And the chart on the right starts to give us a flavor of some of the considerations we might want to think about in terms of this particular activity. So how might we, for example, support cost to serve that's economic? So what's the market penetration do we require? And what's the implications on cost per journey? And this modeling activity is really built on three key activities. So understanding where are consumers in terms of households, being able to understand their order, their composition, or their basket of goods that they are buying, and then finally the transportation costs to supply them. And this work is leading to our understanding of, in urban, highly dense populations, where cost to serve becomes very economic. And we're seeing the proliferation of these e-commerce platforms. And in less urban environments, where this becomes less economic, and there's a trend for retailers to suggest consumers operate a more pickup model at store. And this is supported through digital tools, supply network modeling tools. We've also been looking at distributed manufacturing. And some of you will have heard of this, or where manufacturing takes place to the point of consumption. And so we've been defining what is distributed manufacturing and what are the core aspects that support distributed manufacturing. So around digitalization, localization, the personalization of the product, the use of new production technologies that allow product variety to be produced at multiple scales of production. And one other observation we're finding is in the distributed manufacturing context is the involvement of the user, perhaps in healthcare where it's very personal to the individual, or in terms of other design aspects. So the user is very much part of that supply chain. And this table just summarizes how these 5 aspects of personalization, digitalization, localization, and new production technologies, together with the end user participation, supports distributed manufacturing. The table also shows how digitalization underpins a lot of the new paradigms within manufacturing around Industry 4.0, the virtual enterprise, grid manufacturing, concurrent engineering, cloud-based manufacturing, and smart manufacturing. So a lot of these clearly have some similarities, but in the distributed manufacturing context, all 5 categories are evident and visible. Now, I wanted to share a little bit about our digital modeling tools. One of the observations we've had with industry is when we're looking at new production processes, we often look at unit operations modeling, particularly in the process industries. So that top schematic here on this chart. We then might undertake a manufacturing footprint analysis, looking at the optimum supply network, and often we use different digital tools to support that. And finally, we might look at customer service and inventory implications of that manufacturing footprint, very much looking at service levels at the end user. Now, within organizations, these are often 3 individual conversations, not often very joined up. And certainly the digital tools are often also siloed in nature. And what we've been trying to do is connect these silos of activity so we can look at how a new production process might support a revised manufacturing supply chain and deliver a more effective service offering with lower inventory levels. So these tools are allowing us to connect these technology silos to drive a more end-to-end supply chain perspective, establishing the opportunity, demonstrating a more systems approach through a modeling platform. Now, I want to show some of these activities within Remedies. It's a pharmaceutical project. It's headed up by GSK and is led by the University of Cambridge within our Centre for International Manufacturing. And it has a number of other players, 20-odd partners, AstraZeneca, GSK, technology providers, and universities. And the reason why we've been perhaps looking at this as a consortium, this project has had a bit of a history. The initial consortium set up in 2011. In 2014, the consortium I just referred to, Project Remedies, pulled together a whole series of new players across the end-to-end supply chain, moving beyond manufacturing and including organizations such as Walgreens Boots Alliance, DHL, etc. And this is now continuing going forward. And it reminds me of a key reference or piece of work that we're now looking at, the digital matrix. This is a reference I've just included in the chart, where our initial activity was perhaps an experimentation at the edge of existing technologies, moving to more radical transformation scenarios where we're observing what Venkat refers to in his book, collision at the core, and how these new technologies might ask us to actually reinvent the way we look at our supply chain, but perhaps a reinvention at the root, driven by new technologies. And I'll explain a little bit later about why the platform approach supports this activity. So these are the partners within Project Remedies. It's a £23 million program, just coming to the end of that current phase of activity. And here, what we've been trying to achieve in this program is trying to look at how we might have formulations more customized to individual patients, how might we expedite distribution in hours or days on demand, how might we use smart packaging that supports compliance, how we might use remote diagnostics to look at patient adherence to treatment regimes. So very much solutions that start and end with the patient, enabled through digitalization. I'll talk a little bit more about some of the technologies I've listed here linked to digital transformation. So if I remind, early on, we talked about this concentric circle diagram to conceptualize the supply chain. We had a whole series of experiments that I referred to earlier, and on this chart we've got some of the experiments we've been doing within the Remedies program within pharmaceuticals. So over here you have a digital factory demonstrator site at GSK Stevenage as part of the digital factory. Bottom left we have some smart packaging that we've been developing so we can track and trace high value products. I referred to here about the last mile logistics, where we're looking with Walgreens Boots Alliance and DHL on what's the optimum distribution pathways for medicines. Out here on the bottom right, we've been developing a just-in-time packaging facility. In terms of consumer and patient engagement, a mobile app platform that allows us to look at patient information leaflets and information on how to use patients. So a whole series of experimentations we've undertaken as part of this conceptualization of digital supply chains and how this might support implementation. So when undertaking these experiments, I'm not going to go through all of these value propositions. One of the key areas to look at in our experience is to be very clear as to what objectives we are trying to achieve. Are we looking for more effective integration of data between demand and supply? Are we trying to reduce inventory across the end-to-end supply chain? Are we seeking product traceability, quality, more personalized patient services, etc. And a key aspect of this was our conversations with the regulator. Clearly in healthcare, there's obligations on patient privacy and other confidential issues around data management. So we've been taking our experiments in what's turned out to be a quarterly quarterly forum with the health regulator, MHRA, on some of these experiments. What are the issues we need to think of in advance before taking that experiment too far? And how might this change the regulatory environment? So, value propositions to support experimentation is a key theme that's emerged from our work. Now, moving on to using digital technologies within the production process. A whole series of experiments, this activity led by AstraZeneca around continuous drug substance filtration, continuous direct compression or tableting, or hot melt extrusion and enabling 3D printing. So an activity that would take many series of batch steps, up to 12 or 14 steps with work in progress inventory between those batch steps, moving to a continuous platform, really shrinking the scale of manufacturing and the speed of manufacturing. A much more responsive supply chain is the target goal here. This has allowed us to develop new equipment to support this transformation. And the digital aspect is the process analytical technologies that give us consistency of manufacturing through the production process. Within the packaging environment, we've been developing a just-in-time automated clinical pharmacy. This is at a prototype stage and we'll be going into prototype manufacturing and trials in the coming months. And here, what we're trying to do is, within the clinical supply chain where we're testing new medicines on patients, we're trying to reduce lead time from 4 to 6 months to something less than a week, perhaps even a day, with automated, I should say, bottle singulation, filling, printing, and dispatch. Very much driven by digital technologies. In discussions with the regulator, there's the steps we would normally take to secure the production quality. There's a change of sequence, there's change of sets of activities. Now, the opportunity here is quite significant. Speed to market, reduced patient kit wastage, quicker access to market for new products. That's an example of digitalization within the clinical pharmacy environment. I talked also about network design and connecting these silos of activities. You will have seen the diagram around unit operations, moving to manufacturing footprint implications on inventory, and perhaps looking at sustainability aspects of these operations. And to the right, you can see our demonstrator lab where we are connecting these activities within a suite of digital network design tools. This we're using and applying with a number of organizations at the moment. And this is scenario 9 in our 10 scenario framework about the use of digital network design tools to support improved manufacturing and production. Part of those tools allow us to now capture the complexities of real supply chains. And here's a piece of work we've done with GSK. It's their first visualization of the complete GSK manufacturing distribution network. And it starts to highlight the real complexities of supply chains. You see here 800 odd global locations covering distribution centers, manufacturing sites, multi-market hubs. And these connections can be weighted in terms of the volume of goods or value of goods flowing between entities. So it's not just about managing product SKU complexity, but more about the network complexity organizations face. I talked about last mile cost to serve models. You've seen this chart before, but now I've now included within the pharmaceutical context some details on prescriptions, number of prescriptions. This allows us to use some predictive analytics tools to start to understand what stock is best kept in central warehousing, local at the pharmacy site, and what's the cost to serve if we were exploring a direct delivery model. So using real data from one of our partners on the actual prescriptions in a given location, and using that to inform the viability of cost to serve from an economic standpoint and service standpoint. So just to close off the presentation, a few other insights on some of our activities. We continue to look at quite a lot of activities around pharmaceutical in terms of field experiments and continuous manufacturing. Within food supply chains, we're looking at supply chain integration, resource efficiency, localization of food supply chains. And two projects that we're particularly focused on going forward around organic supply chains and making sure supply chains are indeed what they state they are in terms of the nature of production. And also from an e-commerce last mile logistics perspective, what are the costs to serve and what are the consequences, not just on cost and service, but also on the environment. As part of our network design laboratory, we continue to develop our conceptual and modeling tools around the enablers of distributed manufacturing and being able to test them within our laboratory activity. And finally, in terms of developing our digital supply chain scenarios, we've got a set of activities with a consortium of companies looking at their digital supply chain transformation, using maturity models, for example, for identifying skills gaps, looking at the implications on standards, perhaps necessary enabling activity, and how consortia or platforms are key enablers of that transformation. Within the continuous manufacturing hub, which is a long-term program, we're looking particularly at the future of supply of personalized products and medicines. So how new technologies support microfactory and digital twin concepts, shrinking the scale of manufacturing. And does this allow us to offer a more distributed, more personalized supply of pharmaceutical manufactured medicines? A large program that touches on healthcare. Now, I just want to wrap up on some of the societal implications of these digital technologies. Moving back to the work I've been involved in the World Economic Forum, in a report that was issued last year, we looked at what were the key drivers around the future of production, how might they play out to the year 2030. We talked about technology, regulation, trade, resource efficiency, human capital, and customer expectations. And this led to 4 scenarios we envisage going forward: a disrupted, deterred, devolved, or damaged scenario. And if you look at whichever the scenarios we end up with, or combinations, the role of digital technologies is very significant. So in the disrupted context, you might see an exponential take-up of new technologies. In the deterred scenario, maybe some nervousness on data security, looking at cyber conflict between states, and that might also reduce the adoption rates. In terms of devolved, sharp deterioration in the physical environment due to resources might mean that production becomes more localized, and digital technologies will be fundamental to that distributed model. and damaged where perhaps concerns about globalization might result in perhaps an uneven landscape, and we start to get more localization of production due to forms of protectionism. So in each of these scenarios, we can see digital being a very significant player going forward. Now, another piece of work that the World Economic Forum team commissioned was what was the impact of 4IR, Fourth Industrial Revolution, digital technologies on jobs. And this chart summarizes that initial piece of work, looking at how different geographies would be affected in terms of job creation and what types of impact that might have. And we've just tried to summarize here impacts on R&D and services, which is generally very positive. But pretty much right across the board, a rapid reduction in the number of jobs in logistics and in fabrication or manufacturing. So, something to really think about going forward as to where will the future jobs lie, and will indeed there be a net reduction in the jobs as a result of Fourth Industrial Revolution digital technologies. Typically, we can see something like 20–25% reduction in fabrication in some of the more developing economies. But right across the board, quite a large reduction in logistics roles. On the positive side, significant increases in R&D as well as services. So just to summarize, digital transformation, there's a number of ways of looking at it in terms of conceptualizing and looking at the transformation opportunities, but sector opportunities can be very different. Upstream in terms of the procurement, within the factory in terms of digital design or factory scheduling, automation or continuous processing, or downstream supply chain, which is an interface with the end user. And what we're doing in our current work is looking at the value-add combinations that need teasing out. And these combinations are not easily delivered because they challenge the conventional organizational boundaries we have seen. Now, in terms of our observations, what are our emerging transformation hotspots that we can see? In those firms that are production intensity B2B firms, plant automation, factory automation is seen as a real benefit in improving productivity and costs. In those firms that are directly engaging with consumers, digitalization offers us that extension of firm boundaries, so we can start to better understand the distribution chain all the way through to the end user consumer. That conversation is allowing greater volume and variety flexibility as opportunities as we understand individual requirements. And for service organizations, digital tools allow greater visibility end to end. And they offer opportunities for providing services within that end-to-end supply chain. So digital innovations can be transformative, novel products and services, new industry players, and perhaps alternative business models. Referring to an earlier chart, that's reinventing at the root. Technology is a crucial enabler. Both product technology, production process technology, the infrastructure required to enable this digital transformation. And these changes are often not incremental. So what we're observing is plugging digital technologies into established supply chains may not drive change. Might need to rethink of it in a more revolutionary way rather than an incremental way. Key observation we found is skills gaps are now outstripping technology gaps, and this is contributing to significant adoption challenges. And finally, to close off, societal impacts to the jobs can be significant, engaging with consumers, And finally, the governance requirements and the governance regimes that are required within this new digital supply chain. Now, there's a number of references and resources that are available if you'd like to know more. I refer to our white paper, which is the second bullet on here, but there are some podcasts also and some other publications, some on the World Economic Forum, some from our IFM library, and some of the details there give you some of the academic papers we've just been publishing in this area. So encourage you to engage with that if you would like to know more. And just to close off in terms of keeping in touch, as you can see, research on the digitalization of supply chains is very much an active space for us. Here we're looking at transformation frameworks and models, modeling tools around manufacturing supply network design, e-commerce last mile logistics and e-procurement. And our work in our centre is part of a really vibrant activity in the digital manufacturing theme across the IFM more generally. We do offer some digital supply chain transformation tools. So that framework I shared with you earlier, as part of assessment and transformation roadmaps and ability to share outputs across a peer group, we have a digital supply chain consortium, and anybody wanting to know more can get in touch with Paul. And we're very much following up some of this work to support transformation projects more generally. And finally, to close my formal input to this webinar, some up and coming events. We have our International Manufacturing Annual Symposium in September, 27th and 28th September. We also have a Digital Supply Chain Executive Training course on the 11th of October. And again, those interested, do feel free to contact Joe on the email provided. So very keen that you keep in touch with us both on the research side, myself and Trey Satani leading the work here on digital transformation, Paul Christodoulou on the service activities, if your organisation are keen on looking at digital supply chain transformation, and Joanne Griffiths looking at up and coming events in terms of our symposium and training courses. I will stop there. We have about 8 to 10 minutes left just to pick up any queries on the chat. I can see one from Norman looking at standards. So this morning we've been in a conversation with the British Standards Institute, BSI. Ben Sheridan, Norman, you may be aware of. We've undertaken 2 transformation activities with them. One was a cross-sector activity last year, and this year a number of workshops around healthcare transformation and the impact of digital technologies on the standards within the healthcare arena. And we were hoping to take that out to other sectors as well. I think I'll stop there. I'll thank you for your attention, and do get in touch if you'd like to know more. Thank you very much.